Hello students, welcome you all to my YouTube channel. This channel is best for physics, ICSE class 8, 9 and 10. Every time I am coming near you with a new video, and in my video today I am going to analyze about a topic, refraction of light. To get more videos of physics, you have to subscribe my channel, like my video if you feel it is helpful for you, and give your comment in the comment box. In my previous video, I have discussed about the reflection of light through a spherical surface or spherical mirror. Today, when the ray of light passes from one transparent medium to another, what are the effect of it and which property of light will use here? That what we are going to discuss in this part of it. Let's start today's topic, refraction of light. Refraction is a concept when a ray of light travels from one transparent medium to another. What is a transparent medium? Transparent medium means which will allow almost all the light to go from one side to another. Means which will not absorb any source of light, any amount of light. When a ray of light passes from one transparent medium to another, the changes in speed, changes in the optical density, change in the refractive index will cause some change in its size, in its height. So that what we are going to discuss here in this topic of refraction. So let's start today's topic, refraction. First thing to know what is refraction. Refraction means when a ray of light is traveling from one transparent medium to another. We know speed of light is maximum in air, which is 3 into 10 to the power 8 meter per second. Experimentally, it is proved that no material object can travel in a speed greater than the speed of light in air or vacuum. So when a ray of light travels from one medium to another, because of a change in speed, its direction change. It seems to us a little bit bent. So that's what we can say as the refraction. Refraction means the bending of light rays when it travels from one transparent medium to another. Means when a ray of light will strike to the boundary of two refracting surface, after that speed change and it seems to us it bend or will observe it bend. Sometime it go away from normal, sometime it come toward the normal. So here in this topic we'll discuss the different terms used in refraction. What is the cause of refraction? Why refraction occur? Refraction occur because of the speed change in different medium, because of is optical density. Optical density means the degree to which or the property of a medium to slow down or to change the speed of light. That is optical density. So when a ray of light travels or pass from one transparent medium to another, its speed change, which cause the bending of light rays, which cause the refraction. And in two conditions, will not get any refraction. First condition, when both the transparent medium are same or same transparent medium it will use, or a ray of light striking the transparent medium straight or normal. In these two conditions there is no refraction. And in other condition, when ray of light is traveling from one transparent medium to another, we will get a refraction of light. Here you can see some terms used in refraction. First thing is the incident ray from any source which will give the light, or from any source when a ray of light will strike to the boundary line. Here you can see the boundary between vacuum and a medium. This is the boundary of separation between the vacuum and any given medium. When a ray of light will incident from any source, this ray is called incident ray. And when this incident ray strike to any boundary between two refracting surface or two transparent medium, this point is called point of incidence. And the angle formed between the normal, this one the normal and incident ray will get angle of incidence I. Angle of incidence I. And when this ray of light will come to a second medium, after refraction, which ray will get is called refracted ray. And the angle between refracted ray and normal is called angle of refraction R. Here you can see R. And angle of incidence and angle of refraction are not equal. Sometimes angle of incidence is bigger, and sometimes angle of refraction is bigger. So this all term used in refraction, and like two laws in reflection, we'll get in refraction also two laws where incident ray, refracted ray, and normal all lies in the same plane. And one more trigonometric expression sine, use sine A by sine R equal to refractive index or constant. So that's what you will read in higher classes. Because till now you have not read about the trigonometric expression, so this part will skip. Sine A by sine R equal to constant. That's what you will read in class 10 and class 12. So next one it will come here. Will get that whenever light rays coming from one transparent medium to another, they are having a speed difference. So when we take a ratio between the speed of light in air medium, which is denoted by letter C, and speed of light in a given medium V, C by V will give a constant that is called refractive index. Refractive index is a ratio. Refractive index having no unit. Refractive index only can show us how much, to which degree a ray of light slow down when it is passing from air to a given medium. So refractive index is denoted by n, and also we are using another Greek letter mu. Mu is used for refractive index. If C by V or speed of light in air and or vacuum to the speed of light in a given medium, C by V will get a refractive index n or mu. And refractive index again of two types. One is the absolute refractive index. Absolute refractive index means when we compare the speed of light in a given medium with speed of light in air or vacuum, means C by V is the absolute refractive index. As speed of light in air is maximum, for that reason absolute refractive index always greater than 1. So will not get any time refractive index less than 1. Another type of refractive index or another refractive index that is called relative refractive index, RELATIV, relative refractive index. Relative refractive index means when you are comparing the speed of light in two given medium other than air, that is relative refractive index. That can be more than 1, that can be less than 1. So absolute refractive index means when you take the speed of light in air or vacuum, speed of light in a given medium. And refractive index determine to which level, to which degree speed of light change or light bends. So it depends on the speed of light. With the increase in speed, refractive index decrease. With the decrease in speed, refractive index increase. Both are inversely proportional to each other. So with the increase in one quantity, other decrease. Next one, here you can see denser and rarer medium. When a ray of light travels from one transparent medium to another, one is denser medium, one is rarer medium. So which term will decide, which quantity will decide which one denser, which one rarer? So that quantity will decide, or the factor will decide which is denser, which is rarer medium, that is speed of light. Speed of light is less in medium and refractive index is more, that is denser medium. Whereas in reverse, a medium with speed of light more and refractive index less is a rarer medium. So when a ray of light travel from denser to rarer medium, speed increase. When a ray of light travel from rarer to denser medium, speed decrease. So that is denser and rarer medium. Here we got one more term, refractive index. If it is given to us, refractive index of diamond is 2.42. What do you mean by this statement? This statement means the speed of light in diamond is 2.42 times less in compared to speed of light in air, because speed of light in air is maximum. In diamond, all the particles are very closely packed. So speed of light in diamond is 2.42 times less in compared to speed of light in air. Or in reverse, we can say speed of light in air is 2.42 times more in compared to speed of light in diamond. So this refractive index will show how much time the speed decrease or increase in a given medium in compared to other medium. Here the rules of refraction means when a ray of light traveling from denser to rarer to denser medium, what are the changes will occur? First one, if we look here, when a ray of light passes, if we observe to the first diagram here, case 1. when a ray of light traveling from rarer to denser medium. Rarer to denser medium time, because in rarer medium it is having speed of more and in denser medium speed less. So you can observe here that angle of incidence, angle between incident ray and normal is greater in compared to the angle between refracted ray and normal. Means the light is bent towards the normal. This dotted line is the actual path of incident ray, and the angle between incident ray, actual path of incident ray and refracted ray is called angle of deviation D. You can say D, or it is denoted by a Greek letter delta. This is the angle of deviation produced. Here, angle of incidence is I is greater in compared to angle of refraction R when ray of light traveling from or passing from rarer to denser medium, means more speed to less speed, from air to glass, from air to water, air to diamond. It will come to a reverse case. When ray of light passes from denser to rarer medium, the angle between incident ray and normal is called angle of incidence. Here you can see angle of incidence is smaller in compared to angle of refraction. So angle of incidence is less, angle of refraction is more. Denser to rarer means speed less to speed more. With the increasing speed, it divert, or simply you can say bend away from normal. So here also you can say the angle between refracted ray and the actual path of incident ray is the angle of deviation D, or is the term used, or the letter of Greek use is a delta. So one case, when it is passing from rarer to denser medium, go towards the normal, bend towards the normal. When it is going from denser to rarer medium, go or bend away from normal. When a ray of light strike the medium straight, then what will get? When a ray of light strike the medium straight, angle of incidence is 0 degree, and in angle of incidence 0 degree, angle of refraction also 0. So there is no deviation. Light will go straight. So that is the condition when no refraction occurs. So when a ray of light strikes the medium straight, angle of incidence and angle of refraction both are 0 degree, and there is no refraction. Next one is a principle of reversibility. Means when a ray of light traveling from one transparent medium to another, its speed decrease or speed increase. So change in speed causes refraction. But when the ray of light is coming now, it will observe this diagram. A to O. A-O is the incident ray. OB is the refracted ray. With the same path, if the light will pass from second medium to the first medium, it always passes with the same path but in opposite direction. That's what you can say the principle of reversibility, means light will reverse itself in opposite direction. If the light rays travel from a point A to B over a particular path, it can travel over the same path B to A but in the opposite direction. That is called principle of reversibility. Next one that you can see is the effect of refraction of light. When refraction occurs, what will you get? So first thing here you will notice that it seems to us the stick which is put inside water seems to be bent, or sometimes it seems to us that letter of English letter are rising when you look by using a glass block. So if there are many effects of refraction in our day-to-day life. First one, if we look during monsoon, light passing through water drops, we will able to see the rainbow, which is made of seven colors: VIBGYOR. Next one, when a pencil is placed obliquely, means by making certain angle, that in glass of water it appears to us broken. Or pencil sometimes it seems to us bent. So that one because of refraction. Another one, the level of people observe to a lake or swimming pool, it seems to us little swallow from its original weight, original height. Means it seems to us little bit up. That is because of refraction. That is a shift up to which level it will increase, or it will up to which level it will rise up. This simple observation we can see, if we use a glass of water and put a coin, it seems to us that coin is little bit up. That is because of refraction of light. Formation of mirage in desert. Mirage is a condition where it seems to us the presence of, it will give the illusion or it will give a sense to us that presence of water, but actually not. That is also because of refraction. And early sunrise and late sunset because of this atmospheric refraction and diamond sparkle when light passing through it. When diamond is giving a suitable cut, it seems to us that it's giving or emitting light from all around. Actually not. It's because of refraction of light and also twinkling of star. We read twinkling twinkle little star in nursery classes. That is twinkling of star also a factor of atmospheric refraction. Here people observe when a ray of light is passing through a glass block. Glass block is a cube made of glass. Means in the middle we are keeping glass and both sides air. So first one you will observe here a ray of light incident on the first surface, that is called incident ray. This is the incident ray. And when it will strike from air to glass interface, interface means the boundary, then it will come towards the normal. So here you can see the refracted ray bending towards the normal. Angle of incidence is more than angle of refraction. Again, when it will come to the glass air interface, means when it will enter glass and starting of air, we'll get another ray. This ray is called emergent ray. And the angle between emergent ray and normal is called angle of emergence. E. I1, I2 also we can say, or I and E. And angle of incidence always equal to angle of emergence for a glass block because its two refracting surfaces are parallel to each other. And the perpendicular distance between actual path of incident ray and the emergent ray, this one. This is called lateral displacement, means up to which level, up to which degree it displaced from original path, that is lateral displacement. So when a ray of light passing through a rectangular glass block will get three rays. One is the incident ray, one is refracted ray, and after second refraction will get another ray that's called emergent ray. Angle of incidence and angle of emergence equal for rectangular glass slab because here two refracting surfaces are parallel to each other. When this ray of light now passing through a prism is a three-dimensional object having two-faced triangle and three-faced rectangle. One base and two side refracting surfaces are rectangular and two faces are triangular. Depending upon the type of triangle, this prism name different. If triangle is equilateral, we can say equilateral prism. If triangle is right angle prism. If triangle is right angle isosceles, we can say right angle isosceles prism. And depending upon the shape of triangle, this prism name is different. When a ray of light now passing from one means air to through the prism to air again. Here you can see incident ray by making certain angle when a ray of light hit to the first surface, because here we are having air, this one air, and prism is made of glass. Prism is made of glass prism it will use. Then and last again third medium we are having air. So when a ray of light now strike to the air glass interface here, then we'll get angle of deviation and one ray will get, that is called refracted ray. And after refraction of light, again when the ray of light will come from glass to air, it go away from normal. For that reason you can see here emergent ray which is coming away from the normal or coming toward the base. So the angle formed between the actual path of emergent ray, here you can see the dotted line, actual path of emergent ray, and here you can see the line PM, the line passing through the PM up to L point. That is the actual path of incident ray. The angle formed between them is called the angle of deviation, which is denoted by D or denoted by the Greek letter delta. It will come to the equation of prism I plus A equal to A plus A, I plus E equal to A plus D. I plus E means angle of incidence plus angle of emergence is equal to angle of prism. Angle of prism means the angle formed between two refracting surface. Here this A point, this angle is called angle of prism. The angle formed between two refracting surface is called angle of prism. So angle of incidence plus angle of emergence give angle of prism plus angle of deviation. I plus D equal to A plus D, and some book it is written I1 plus I2 equal to A plus delta. Delta is the angle of deviation, I2 is the angle of emergence, and I1 angle of incidence, or you can say I plus D equal to A plus delta or A plus D. Next in our discussion is the atmospheric refraction. So whenever ray of light is passing from one transparent medium to another, refraction occurs, sometimes multiple refraction occurs. So first, let us discuss here about the dispersion of light. Dispersion of light means we are having two type of light. One is monochromatic light. Monochromatic light means single color. One is polychromatic light, which is the multiple color. When this multiple color light rays will pass through a glass prism, it will change into different color. If we take the example of white light with a combination of seven colors, when it pass through glass prism and will put in a screen, we'll get seven color VIBGYOR in a systematic arrangement of visible light. That property or that separation is called dispersion. Dispersion of light will able to see in case of a rainbow also. When a white light pass through a glass prism, here you can see violet to red, where they have arranged in different pattern. Because what is the cause of this dispersion? Because light rays having all these color are having different wavelength, and all the color are having same speed in air or vacuum. But when this light rays will pass from air to any other medium, their refractive index change, their speed change. And red light which is having more speed can be seen to us fast, which is violet light which is having lowest speed, it come down. So depending upon the difference in speed, because they all travel in different speed, we'll able to see a pattern VIBGYOR. So because red is having maximum speed, so refractive index of red is less in compared to violet. So refractive index of a medium is different for different color of light and speed different. That is a region that will able to see a pattern of color. And all this pattern of color red, orange, yellow, green, blue, indigo, violet all are called spectrum. The band of color formed after dispersion is called spectrum. SPECTUM spectrum. TRUM. So spectrum means the band of color formed after dispersion of light through a glass prism. And in case of rainbow, the water droplets are behaving like glass prism to give us a pattern of different color. There is no boundary of separation between all these color, because this, for that we are not able to identify properly which is which color. So this is the visible light VIBGYOR. Next in the discussion about the atmospheric refraction, means when a ray of light passing through or coming from sun and passing through the atmosphere, it will suffer multiple refraction. And the refraction occur in our atmosphere is called atmospheric refraction. In atmospheric refraction, first effect if we look here, early sunrise and late sunset. Means when a ray of light is coming from vacuum to the atmosphere, vacuum rarer medium, where speed more, atmosphere denser medium where speed less, so it comes towards the normal, back towards the normal. That is the region that seems to us the object is little bit off in case of early sunrise. And in case of sunset, its actual sun is down, but it seems to us up. So that is because of the atmospheric refraction. That is because of speed change. That is because of the vacuum and atmosphere in which refractive index is different, in which speed of light is different. Next one, the twinkling of stars. Twinkle, twinkle, little star. Little star because they are a far distance that seems to us smaller. Twinkling of star because when a ray of light is passing from the star to the observer, but we all are the observer, at that time light is coming from vacuum to the air and moisture in them. So whenever light is pass through atmosphere, atmosphere having density different, atmosphere having water vapor somewhere more, somewhere less, air quantity somewhere more, somewhere less. That is the region that one time speed is more, one time less. Because of the multiple refraction of light, seems to us sometimes star is nearer to us and sometimes far, or the distance or the position fluctuate due to the multiple refraction of light. That is all about the refraction. Atmospheric refraction, refraction through a prism, or refraction through a glass block. So to get more videos, subscribe my channel, like my video, it will feel it is helpful for you. Thank you.